Hello, everyone. I'm super happy to be here and to be able to speak with you. And welcome to my talk. Let me screen share. You should see my slides now. My talk is titled Build Your Kubernetes Operator with the Right Tool. But first, a few words about myself. So I'm Rafał. I'm from Poland. I'm a tech team lead of the cloud native team at Hazelcast. And before I worked at Google and CERN, I'm also an author of the book Continuous Delivery with Docker and Jenkins. And from time to time, I do conference speaking and trainings. But on a daily basis, I'm a developer, I'm an engineer. And I live in Krakow in Poland. That's from where I'm speaking to you right now. A few words about Hazelcast. So Hazelcast is a distributed company, and it is distributed in two meanings. One meaning is we basically produce distributed software like Hazelcast in-memory data grid, which is usually used for caching and for in-memory data store. Second product is Hazelcast Jet, which is a library for stream processing. And Hazelcast Cloud is Hazelcast as a service. But there is also a second meaning to why we are a distributed company. And we are distributed because we were always a remote company. So we have people all over the world, and we have some people in Europe, some in the US. So we are global. Our agenda for this talk is pretty simple. So first, there will be a short introduction, and I will set up the context and what is an operator and how to use it. And then we will walk through all possible ways how you can implement your operator. We will start from the most popular solution with using operator SDK with Helm, Ansible, and Go. And then we walk through some less popular solution like using some other operator frameworks. And then we will end up with the most maybe not difficult but time-consuming way, which is writing an operator from scratch in your favorite programming language. And while I will be talking, I will always give you the pros and cons of each solution, because there is no one choice that is like better than all others. It's always a trade-off. So let's get started. So the entry for this talk for you is you would like to build a Kubernetes operator. And now the question is which tool to choose. Should I use operator SDK with Helm, Ansible, Go, or should I go with Python, or Java, or any other programming language? But first, what is really a Kubernetes operator? So by definition, operator is an application that watches a custom Kubernetes resource and performs some operations upon its changes. So this definition is very generic because the operators themselves are very generic. So to make it maybe a little more digestible, let's focus on one example of the operator that we will use throughout this talk. So this example would be to create an operator for Hazelcast, because I work in Hazelcast, so it's just easy for me to grasp. And we'll use this operator to create Hazelcast cluster. And actually, the only parameter for us, just to make it simple, would be the cluster size. So as a user of the operator, I would like to specify such a resource. And then, so it's like a Kubernetes native resource. And the only parameters is cluster size. And then when I create such a file, I would like to apply this with kubectl, and I would like to see my Hazelcast cluster created in Kubernetes. So in this example, we can look how it all works. So as a user, you create this, you modify some resource, you create some Hazelcast resource, and now the operator is an application that watches the Hazelcast resource and interacts with Kubernetes API to create or update like the deployment or with the given number of Hazelcast replicas. So this example is pretty simple, but you can imagine in real life, you can do much more complex operations. For example, some cleaning some data in Hazelcast cluster, or upgrading Hazelcast version, or sending some metrics, or doing a backup, or restoring a backup, or just anything that you really want, you can do with the operator. So there's no limit here. The point is that operator is something you write, so you can write any logic you want. Now, since operator is so generic, you can actually write it in anything you want. Operator is just a Dockerized application running in Kubernetes, so technically you can write it in any programming language you want. What's more, like Kubernetes API is just a REST API, so you can really use whatever you want. So here in this slide, you can see like all possible options. But now, like, no matter which option you choose, there are some things that are in common when you will be developing an operator. So no matter if you implement your operator in Java, operator SDK, or some frameworks, you will need to, your first step with the operator will be to implement the operator logic. Second step, you will always need to build a Docker image from your operator and push it to some registry so that later you can deploy it in Kubernetes. First step would be to create custom resource definition with the definition how your custom resource should look like. Then you will always need to apply some role bindings because your operator needs some access to some permissions to Kubernetes clusters, so you need it. Then you deploy the operator. So then, using these permissions, you will make your operator running. Like, your operator is an application, so you need to deploy it to Kubernetes. And finally, you will be able to use your custom resource, and then operator will watch for this custom resource and act upon the changes. So now, if we look at the steps, so the only step that actually will be different for different operator implementations will be step 1. So you will implement the operator in a different manner, but all the rest will be the same. We will always need to Dockerize it, so Docker build, Docker push. We will need to create custom resource definition to specify how your custom resource look like. We need to some permissions for the operator. We need to deploy the operator. That's all the same. And we need to finally create our custom resource. That is why in this talk, I will focus on the step 1, so how to implement the operator, but I will always give you the context and the commands how to do all the other steps, but that they are the same. So with this knowledge in mind, we can start going to the point. So the first option you have, if you would like to build an operator, is to use Helm with Operator SDK. So Helm is a package manager for Kubernetes. So it allows you to create a set of templated Kubernetes configurations, package them into a Helm chart, and then render them using parameters specified in a values YAML. So Helm is very simple to use because creating a Helm chart requires no more knowledge than defining standard Kubernetes configurations. Because Helm charts are basically your Kubernetes configuration with some templated values. You can see it this way. So in our example, we will create a Helm-based Hazelcast operator. And so we first need to have Hazelcast Helm chart. So first, how to create a Hazelcast Helm chart. So you can use Helm create chart, and then you can look at this. This is all the code we need. So we need the deployment file. So we will use deployment to deploy Hazelcast cluster. And you can see all these values in the brackets, double brackets. These are templated values. So one is the, we always have it in a Helm chart, so this Hazelcast full name, so it's just the name of the deployment. And our only parameter is this value size. And we specify, as a user of the Helm chart, we specify these input parameters in a values YAML file. So when we have our Helm chart, then the next step is to generate an operator from the Helm chart. And you do it with operator SDK init, operator SDK create API, 2 commands, and the operator is generated. And then we need to build it, build the Docker image, push it, create CRD, custom resource definition with make install. So this make install is a command from operator SDK to simplify creating custom resource definition. Then we deploy the operator with make deploy. This is also a simplification from operator SDK. And finally, we can specify our custom resource, and operator using this custom resource will create a Hazelcast cluster for us. Let's look how it looks in practice, because it's always better to see like how it all looks in practice. So under this repository, I will share this link at the end of this talk. I created actually all the ways to create an operator, so you can really go here and play with it. And that's what I encourage you to do, because one thing is listening, the other is playing with that. And with this repo, you can very simply go to the repo and just execute a few commands and see how operator looks like in different programming languages. So our first example is Helm. So if I open Helm, here are exactly the commands you need to perform. Just for you to, so I have already this in my VS Code. So we can look at not Java yet, but in the Helm. So in the Helm, as we've seen on the slide, in the chart, we have all our Helm charts. So you see the only parameter is size, and our templates is this deployment file, exactly what we've seen on the slide. Now from this chart, I generate the operator. I actually already did it with these 2 commands, so I will not do it again. And then what I need to do is execute this command to now first build Docker image from the operator and push it to the registry. The next thing we'll need to do is to make install, which will create custom resource definition for us in our Kubernetes cluster. Okay, so you see the custom resource definition was created in the cluster. And finally, we can deploy the operator with make deploy. Again, make install, make deploy. These are the things from which are given us by the operator SDK framework. So it deployed all the role bindings and deployed the operator. We can see the logs of the operator. So these are the logs of our operator application. So as an ops guy, I deployed the operator, and now to create and this gives a user the opportunity to create Hazelcast cluster with custom resource. So how the custom resource looks like, we've already seen it on the slide, but I will show it to you again. It should be here. Samples, yeah, this is our custom resource. By the way, it was generated also by the operator SDK. So you see the only parameter is the size. So here we can see the operator logs. Now, if I create our custom resource, I need to apply this file to Kubernetes. And then when I apply these things to the Kubernetes, then operator watches for this resource. So we should see, yeah, operator, okay, said, okay, I've seen some new resource. I will act upon this, and we should see that it created Hazelcast deployment. Yeah, we can see it, and deployment obviously created a Hazelcast pod. So we have our Hazelcast cluster running with the size 1. Now, if we would like to change the size, the only thing we need to do is like, okay, I would like now to have size 3, apply it again, and the operator application, which is watching for this, already seen the change, and we can see that new pods are being created. And we have 3 Hazelcast members running. If you are interested in it is not in the Hazelcast logs itself, you can see that they formed one Hazelcast cluster, but that is not the most important thing for this talk. Okay, so the last thing, we need to clean it all up. So I really recommend you walking through these examples. So let me just reiterate. So you see, like from the Helm chart, it was very easy. We created a bunch of templated Kubernetes configuration, created Helm chart, and generated the operator. Now, Helm chart is somehow limited, and if you look on the internet, you may see something called operator capability levels, which basically, this graph basically means that you cannot do everything with the Helm chart, which makes sense because just using common sense, Helm chart is just a template, so you cannot do any custom complex operations because you cannot write like a logic like you could do in a generic purpose programming language. On the other hand, it's very, very simple. So if you decide to use Helm as a base for your operator, it means that your implementation is very simple because you do it in a declarative manner, not imperative manner, but in a declarative manner. And if you already have a Helm chart, then there is no work at all. And it will be limited to the features available in Helm, and everything is generated for you, so not much work on your side. Second option you have is to still use Operator SDK, but this time with Ansible. What is Ansible? So Ansible is a very powerful tool for IT automation, and its nature is also like Helm, it's declarative, but thanks to the number of plugins and thanks to possibility of scripting, you can actually perform any complex operation, DevOps operation you want. And Ansible has a plugin for Kubernetes called Community Kubernetes, and is dedicated to interact with Kubernetes API. And what's more, Ansible is from Red Hat. Operator SDK is from Red Hat, so they make it. So they made it a first-class citizen, so you can generate an operator from an Ansible playbook. That's it. And we will see how to do it. So if you go with the Ansible direction, what you need to do is first to initialize your project, and Operator SDK create API that will generate will scaffold all the structure for your operator, and then you write the operator logic in using this Community Kubernetes plugin. And you can see like this Community Kubernetes plugin actually looks very similar to what we've seen with the Helm chart. It's a declarative way. But keep in mind that this time we are like, there's kind of an abstraction layer of Ansible. So this configuration is first passed to this Community Kubernetes plugin, and only then to Kubernetes API. So there is some layer in between. If we would like to deploy this, all we need to do is actually the same what we did for the Helm. So build the operator, push it, make install, make deploy, and that's it. And it works exactly the same from what we've seen with Helm. Now, with Ansible, you can do anything you want. So it seems like from what you've seen, you may see it's like way better solution than Helm. But I can already tell you that people don't use Ansible for operators so much. And that is because Helm is super simple and Helm is very well fit in this cloud native world. And Ansible is kind of does not fit there so well. So people usually don't use Ansible for creating operators. But if you do, what it means for you, you still write your code in a declarative manner. You can use this community Kubernetes plugin. You can cover anything you want because Ansible is actually a very powerful tool. And since it uses operator SDK, a lot of things will be generated automatically for you. Next option is Go. Operator SDK with Go. So Go is a general purpose programming language, so you can technically write anything, any logic you want, you could ever imagine. And what's more, like the whole Kubernetes environment is written in Go, so it's a it's a good fit for writing. So there is no better Kubernetes client than the one written in Go. So that's very good. And Operator SDK supports Go. People used to write operators in Go even before using Kube Builder, but now Kube Builder is integrated into Operator SDK. So basically, Operator SDK is the best way to build operators with Go. How it looks like. So again, you need to Operator SDK init, Operator SDK create. This is the same. And then you write your logic in a Go language, also using some comments with some special comments which will generate, for example, this comment, this Kube Builder airbag groups will generate role binding files for you automatically. And now what we can see, it's like we write the code. So we are developers. We no longer write configuration, we write the real code, which is good and bad. I mean, good is you can write anything you want, but the bad side is more difficult. It's easier to do some mistakes because we really need to cover every logic. You can already see. So what we do here, we check, okay, if deployment of Hazelcast is already created. If it's not found, then create it. So it's like then it's not even the whole code. The whole code you need to cover. Okay, if it's found but the size is different, we need to change it. So you really like write the logic in an imperative way. So doing step by step. This is how the specification of our deployment configuration looks like in Go. And on the right side, you can see how the input, so how the API, how this is our custom resource definition. So it's you can already see that it's way more complex, but it gives you way more options, and that's why people in general use it a lot. So to build it, I mean, if you have it implemented, it's the same. It's like the same commands because it's, after all, it's Operator SDK. I will not build it here, but again, I recommend you going here, build your operator, going to the Go and looking at this project and running this on your own. One thing that I would like to show to you is in our Go implementation, we write it in the controllers. This is in the controller, it is our logic. And I wanted to show you that this file is really long. I mean, it's okay. Part of this was generated, but most of the thing I had to write, and you will have to write if you implement it in Go. So really, like, get Hazelcast resource. If not found, then okay. If not found, then we need to create it. Deployment is not found, then we create a deployment for Hazelcast. If if we found it, but the size is different, we need to update it. So you see, it's like it's a lot of code, and it's I would say pretty complex for what we would like to do. So we just want to create Hazelcast cluster with one parameter, but it's pretty complex. Short summary. So if you go with Go, then implementation is imperative. So it requires writing more code and caution. But the Go is very well integrated with Kubernetes. Kubernetes is written in Go, so you cannot have anything better. You have no limits on functionality because it's Go is a general purpose programming language, so you can write whatever you want, and all the boilerplate files are automatically generated. So that's good for you. Less code, you don't have to write all this boilerplate code, and we will have to write it in the next step, which you will see. Okay, we covered like Operator SDK. Operator SDK supports Helm, Ansible, Go. I can already tell you that Ansible is not really used. So with Operator SDK, you will either go the easy way with Helm or the complex way with Go, depending if the functionality of your operator needs to be complex. But that is not the only way you can implement an operator. So there are two other like big options. One is to use some other operators frameworks, but not Operator SDK, because there exist some other operator frameworks. And that's what we're going to cover right now. Using an operator framework, which is not Operator SDK, because Operator SDK is the mainstream, but we can do some other ways. So I looked on the internet and checked for some operator frameworks, and there are many of them. Here I listed 5 of them, which are like which were first to find, and you can see they are for different programming languages. Now, what would you do if you just find on the internet something? So first, you need to evaluate if someone is really using this, because otherwise you don't want to use a framework which was written yesterday but by some student or something. So you would like to get it stable. So the first thing you can check is the number of GitHub stars, and then you can already see that probably C# is not a way to go. This Node.js operator framework is not a way to go. Maybe Java, maybe Rust, but this Python KOPF framework looks the most promising. And if we look even deeper, you can see that this was a fork of a project which had even more stars, almost 1,000. And if we look even closer, we can see that this framework was developed inside Zalando, so it gives it some credibility. So let's try to use this KOPF framework. So how to create an operator with the KOPF framework? So we need to, there is no code creation, so we will need to implement not only the logic, but also this boilerplate, like the Docker file, the custom resource definition, role binding, operator YAML, and finally Hazelcast YAML. So we implement the boilerplate code, and then we can implement the operator logic. I will show you the boilerplate code, but it's not the most interesting. So let's move straight into the operator logic. So how you write an operator logic with this KOPF framework? It's actually very elegant. So it's a Python general purpose programming language. So you write the code. You are not longer running configurations. You specify like YAML templated file, but templated in a way of Python, and then fill it with the Python language. But it looks pretty clean, I would say. This code, what we see here, and thanks to the Python decorators, it's actually quite nice because you can specify KOPF on create. So this method will be executed when an operator realizes that, okay, this resource defined in this annotation was created. So it looks pretty good. And when we have this operator logic, then we have to execute these common steps to get it working. Again, I recommend you looking into this in details, but let me show you the most interesting things. So first interesting thing is there is no scaffolding here. All the files you can see here, I actually had to write. So what files we have? Let's look into that. So we need to write a Docker file for our operator, which will basically install the KOPF framework and add our operator Python and start it. We had to run the CRD. So this is definition of our custom resource. Before an operator SDK, it was generated. Custom resource, okay, and in any case, we needed to write, this is our input for our operator. The operator logic. So part of this we've seen on the slide. So this part is responsible for acting on a resource created. So if a custom resource is created, this method will be executed. This method is executed if the custom resource was up. And this is basically the inlined the deployment configuration. Now, what else we have? Like this is again, it was not in operator SDK. This file was generated with this. You remember, make install, make deploy. But here we need to write on our own. So this is the deployment file for the operator application. And the role and role binding, so the permissions operator needs are also, we need to, before it was generated, but we need to write them here. But if you look at this logic, it's actually very short and it's very, very nice, I would say. So I really like this framework. So I encourage you to play with it. So these are exactly the steps you need to run the operator. So if you choose like an operator framework, which is not operator SDK, what it means to you. So you are in the much less popular world. So, you know, you probably will need to also contribute to these projects because they are not so popular. Even 1,000 stars with this KOPF framework, it's not that much actually. So you need to know this. And there is no project scaffolding, boilerplate code generation. So you're on your own. You need to do it. But Python or any programming language is like there is no limit on functionality. And if you choose a language and a framework, make sure that it has good Kubernetes client. For most of them, it will be okay. But remember that no client is better than Go Kubernetes client. That's it. Okay, the last thing left is let's say you don't like operator SDK and you don't like any operator framework. You would just like to start from scratch on your own. You can still do it. And I know a lot of companies that are doing this, so it's not that crazy idea actually. So using a bird programming language for your operator. So remember, like operators are nothing more than Dockerized applications. So technically you can write them in any programming language you want. But such a solution means you are on your own, so there is no boilerplate code generation. You just need to write a lot of more code and think about more things. In an example here, I will present you something I actually found on the internet in one blog post that I will put a resource at the end, which is how to create a Kubernetes operator in Java using Quarkus framework. Using Quarkus framework. Quarkus is good because Quarkus has this promise that you can compile your application to a native Docker image, so it's very fast. That's it. So Java plus Quarkus, how do you need to do it? So you need to implement all the boilerplate codes, all the boilerplate files, the same as with Python, because there is no scaffolding, no SDK to help you. And then you need to implement a lot of Java classes with the operator logic. How does Java classes look like? So this is just a part of the code. So in this example, we use Kubernetes client, I think Fabricate Kubernetes client, and we write the logic the same what you've seen in Go. Actually, so but this one is in Java, so you get deployments and filter them by something, and then okay, the deployment is empty, then we create a new deployment. If it's not empty, then we set another size. Imperative logic, step by step. But obviously, like in Java, you need to write a lot of other things. So these are the this is another like client provider with the support, like providing Kubernetes client in the Quarkus framework, and you have to write a lot of more code, this and Hazelcast resource, and so basically like but I think if you start writing operator in Java, you must like Java, and you are probably used to Java as a very verbose programming language, so you're probably used to writing a lot of boilerplate code. I will not go into details into that because like it's you need to try it. That's the thing. How to build it? So I told you that Quarkus has this premise that you can build a native Docker image, but you can also build the normal Docker image. So if you Maven package and Docker build that the normal Docker image, but you can also compile it to the native Docker image, which runs way faster. And then after your image is built and pushed, then you can apply these common steps to deploy your operator. Show you one thing. So yeah, I need to close it. So if we look at this Java example, so it all looks good actually. So but you have to write your Docker file. So nobody will write it for you because there is no SDK here. But you see, it's a lot of code. That's what I wanted to show you. So it's like really you need to write a lot of things. But as I told you, I mean, it's Java, it's verbose, but it has some. It also has some benefits, as you know. Okay. So again, please try it on your own. I really recommend. So what it means to you, if you choose not to use any framework, not to use any SDK, it means writing a lot of more code, and you better check first if this language has a good Kubernetes client, but you have no limits on functionality. And I wrote here, the only reason for this is actually if you would like to have a single programming language in your organization, or you need the language for some reason. For example, your tool is written in Java and you would like to have an operator in the same language to interact with the tool, or some reasons like that. These are good reasons why you would choose your language of choice for the operator. Short summary. So you've seen different ways of creating an operator, but now which tool should I use for my operator? So one thing you could do is you can go to the repository, and which I will share, and just check which you like the most, and then write choose your way. But another approach is to see what other tools do, because you don't want to be on your own writing operator. You would like to use Stack Overflow for your questions, so you can check what other people do. And I did it for you. So I checked what languages, what approaches other tools chose for their operators. So in case of Prometheus, they went with Go. CockroachDB, they used Helm. Datadog, they used Go. Snyk, they used Helm. Jenkins, they used Go. Redis, they used Go. So you see already a lot of, you already see the trend. But I went even further. I checked all the operators in the operator hub and checked the statistics. And these are the stats. So you see the vast majority is written in Go. There are some of them written in Helm, and there are some in Java, but really most of them written in Go and Helm. So that's if you choose Helm or Go, basically you are in a good company. So I created some hints. So if you still don't know what to choose, I would say if you already have a Helm chart and your software don't need any complex capability levels, go with Operator SDK and Helm, because that's super simple. You don't need more. Hint number 2. If you want to create your operator quickly and you don't need any complex capability levels, again, go with Helm, because Helm is very, very simple. Hint number 3. If